Okay, everyone. I'm just going to point you to some other links that are going to be really useful for you today. So if you have the repository, in the README, there are a bunch of links down here under the setup and links section, and we'll be going through all of these. Okay. So first one that's really important, you'll need this in order to run anything, and that one is Node.js. So if I click that link, so who does not have Node.js installed on their computer? Anyone? If you've come to any of the other workshops, you should. But if you haven't come to any of the other workshops or ever used this before, you might need to install this one. So that's the first thing. So make sure this is installed. The next thing you're going to want after that is MongoDB. So you're going to want two things installed on your machines. One of them is the community server. So this is essentially a local version of the MongoDB database that you can just run on your machine. And so that's really useful for testing purposes. So grab that and install it as well. And the other thing to do with MongoDB you're going to want to install is this one here called Compass. And what Compass is essentially a database browser. So a GUI that lets you see and modify, interact with the contents of any MongoDB databases, not just installed on your computer, but you can use it to connect to cloud databases and browse those as well. So I'd like everyone now to make sure that they have those three installed on their computer. So Node.js, the latest LTS one, is absolutely fine. If you already have it on your computer, I really don't think you'll need to update. Just the version you already have will be fine. And then MongoDB Community Edition for your local version of the database, and Compass for a DB browser tool. So this will be step one of today's workshop. So please get those three things installed and stick your hand up if you'd like any assistance with that. Resume recording. And you would want to use the free version here. You can name it whatever you feel like naming it. I'm just going to call it this, but you can call it whatever you like. I'm gonna not tick this. I'll just leave everything here as default. And click create. Hey, traffic lights. It's
Sorry, what's your name?
Andrew.
Andrew. So I think there's a student who had a question. Well,
Yep.
with the local MongoDB, and I don't know too much.
Sure.
To be able to help.
So I think someone is in the previous step, they asked me for MongoDB, to install the complete or custom version.
I can't remember. It's been so long since I've had it on my computer. The default
I guess I'll do it in place.
Yeah. Yeah. Default is good.
Which
I suppose so. You definitely go
Can someone who has a bag and it knows how to start the ingredients of also back? Yeah, and I thought, no, yeah, I don't know
Sorry, once in the previous step, and they're trying to get down. They need to get it through the terminal or download the package. And then I don't think probably that's the complete. Because it's through the package, not through the terminal. Maybe I should try to do the terminal. Nice.
Yeah, should we? I think it's not like, no, I reckon that's what. I think we have a USDC.
Didn't he plug it into USB-C? Hi everyone. If you're struggling with downloading the community server, I reckon the easiest way is to use Homebrew. So you can just go to brew.sh and then install it like this. And then from Mongo Atlas, it will give you the instructions to install it using Brew. If that helps anyone. If you're on Mac.
I was trying to follow the same step because I was trying getting MongoDB, but they're on Windows. So should we try to get this installer instead of NAS, or we can brew for Windows?
There's Scoop, which I think might do it, which is the equivalent of MongoDB.
Just skip brew.
Are you sure there's not? I thought there'd be like an executable file they can just download, like an MSI.
Yeah, but they were struggling with that one too, in the configuration for it, but we'll try again.
Okay. Do you want a fiber try? That would like.
I can.
Yeah.
Okay, everyone. So now that everyone has some version of MongoDB working, either they've got a community on their computer or they've got an Atlas cloud ready to go, then what you're going to do is if you open up Compass, you'll see a window that looks something like this. And by default, you'll see this new connection thing, and the connection string that appears here is the default connection for your local machine. So if you installed the community server on your computer, you can just leave this as the default and click connect. And then if everything worked, you'll see something that looks like this. Obviously, you won't have all these databases on your computer. That's just something that I have on my machine. But what you can do is once you're in here, you can create a new database. And you can do that by on the left-hand side here. If you go to databases and then you click the plus button, and then you can give it whatever name you want. It really doesn't matter. I'll call this my WDCC database. And then a a collection name is like, if you're familiar with SQL databases, you might be familiar with database tables. So a collection name is like your first table that you're creating in this database. And I'll call this, I don't know, my stuff. You can call it whatever you want, or just stuff. And if I go create database, then we'll see in here. So there's my database, and here is stuff. And basically for MongoDB, so just show of hands, who's used SQL databases before? Just so I know. So quite a few of you. That's good. Who's used any non-SQL databases before? So quite a number less of you. Okay, that makes sense. So MongoDB is not an SQL database. It's a NoSQL database. And another name for it is a document database or a document store. And essentially what it does is, rather than having all these tables and relationships between tables that you might be familiar with from SQL databases, is it has these collections. The one that I've created here is called stuff. And a collection is just a bunch of documents. You just put a bunch of documents into the collection. And by default, there's no constraints on the kind of data that you stick into one of these collections. They're kind of like JSON-like data. So for example, if I click add data here, and if I click insert document, then the kind of insert document thing here, it kind of looks like JSON. And I've got an ID here, which is like a unique identifier. And then maybe I'll put a name, and that can just be a string. I'll call it name Andrew. So I'm just entering what is essentially a JSON document. I'll put phone number. This one's a number, 1, 2, 3, 4, 5, 6, 7. There we go. Just put whatever data you want. I spelled that wrong, but that's fine. And then once you've created the document that you're trying to insert, if you click insert, then you'll see that it has appeared here. And now if this were an SQL database, then maybe this would be a database table, and that table would have an ID, a name, a phone number, and an email column. But this is not an SQL database, so I'm not constrained to that rigid structure. So for example, if I go in here and click the edit button, which is on my right-hand side here, then I can start typing. So this phone number, it was a number. But if I click on the right here, I can just change what it is. Okay, so now my phone number is a Boolean, and it's true. That doesn't make any sense, but that's what it is. I can click a plus button here if I hover over one of these line numbers, and it says add field after phone number. So if I click that, then now I'm adding a new field. And okay, that can be a string. So I'll just add some text in there, and I'll click update. So I was quite easily able to change the kind of data that's stored in this document. And then if I wanted to say add a new document, if I click add data again, insert document, and then this one might have some other data here, something else, some number, then click insert. So I've got 2 documents in this same collection, and they look very different. So you can do things like this when later on, when we're actually adding database connectivity to the contacts app, we'll see that we can create a schema that does more strictly specify the structure of the data that can go into these collections. But just working with MongoDB, Compass, and playing around with the collections themselves, you really can just store any kind of data that you want in here. That includes other things. So for example, if I go edit here, I'm gonna add a new field to one of my documents here. And I'm gonna call this, I don't know, I'm not very imaginative, so I'm gonna go my array. And then I'm gonna give this a type of array over here. And so now I can, if I click edit again, I can start adding as much information as I want into this array. Yes, add one, add another one, and add another one, and click update. So that's something that you can't really do in an SQL database as well. You can have arrays of stuff as part of a document. If I wanted to do something like that in an SQL database, I would have to create a whole new table containing that list of data and then link that using foreign keys. So in that way, it can be quicker to get started with playing around with the kinds of data that your application is working with. And it doesn't just have to be arrays of strings like I've got here. Like I could add, for example, another field here, and this is going to be an array. And I'm going to add an item to that. There we go. Let me just update that. And then within the array, for example, I can make this one. I know this is a Boolean, which is going to be true. This one can be a string. This one here, I'm going to make it another object. So I can have really complicated nested structures. So if I add a field to this, better click the update button there. Add a field to that. Food. So I've essentially got, an object here that has an array of stuff, and that array of stuff is a Boolean, a string, another object that has its own field. So you can build up pretty much arbitrarily complex data structures in these documents. Whereas for SQL databases, everything is just a table. And if you wanted to build up more complex data structures, you would need to start composing multiple tables worth of data together using joins to represent the same kind of thing that I can just represent in one document here. So that's the benefits of something like MongoDB. I think it's a lot faster to get going and playing around with the data that your application needs. Some of the drawbacks would be, that lack of structure, I guess. If you have a well-defined schema, then maybe if you put that well-defined schema into an SQL database, you'll be able to take advantage of some of the optimizations that SQL database systems have, which can give you much better performance. So that's one thing that is a benefit of the SQL database. It does actually do a better job at enforcing your data to be the way you need it to be, and it can be faster as well, depending on how you've optimized your queries and things like that. Let me just create a bunch of JSON and add it to this collection real quick. So I'm just going to delete these random objects here. Delete. And I'm going to import a JSON file. I don't really have one on hand, so I'm just going to pop over a nice little ChatGPT real quick to generate me some data. Generate JSON data for 10 Pokemon. Sure. Each one should have a name, dex, entry, dex number, and an array of types. Each type should be a string. Let's see how good ChatGPT is at that. It's usually pretty good at doing things like that. Yeah. Cool. So you can use ChatGPT to generate whatever random data that you want. I'm just using this Pokemon data. I'm going to copy that and I'm going to paste it in here. So if I go import data, I suppose I'm just going to go add data actually, and I'll paste it in here. Insert. There we go. So now I have a bunch of data, and this data has the same kind of structure. So everything has the ID here. I didn't specify that. The ID field _ID was automatically generated by MongoDB. So every document needs an ID. All the other data here was in that JSON that I just pasted in. So everything has a name, dex entry, a dex number, and then an array of types. Now, let's say I have some data like this and I want to search through this data. That's a really important thing with databases, is to be able to actually query the data that's in your database. So within Compass, I can go up here to the top and I can do a query. So for example, if I say name Bulbasaur, so this is a really basic query, and I click find, it will give me the thing that matches name equals Bulbasaur. Let's say if I wanted to do a more advanced query, so let's reset that. Let's say if I want to do a query for dex number, and let's say if I wanted to get everything with the dex number of less than 5, for example. So let me see if I can remember the syntax here. I believe it's $LT and then 5. I might need to put squiggly brackets around this. Yes, it's let's do, yeah. This is right. So my query is dex number : and then squiggly brackets $LT : 5. This should give me everything with a dex number less than 5. Let's see if that works. It gave me 1 and 4. Is that right? 1, 4, 7, 25. Yep, that looks like it was the correct data. So it gave me Bulbasaur and Charmander there. Similarly, I could go dex number greater than 25. So that's $GT. And if I find that, so it gives me everything except Bulbasaur and Charmander there. Let's say if I wanted to say, okay, give me everything whose dex entry contains the text sharp. So if I go dex entry, and then so if you type $, you can sort of find a bunch of things here. Not sure exactly which one it is. Search for one thing I like doing, by the way, is having the MongoDB documentation. The query substring. So if I go, I can probably do it using a regular expression. So that's a way of searching for a substring. There might be others. If I just type this with quotes, yeah, that didn't work. I didn't think just that simple would work. So I can do other things. So let's say if I wanted to find everything that's a grass type, so I'd want to search for, I want to sort of search in this array. So I could go types, and then if I put grass in there, I think this would work fine. No. Do I have to put the array around it? Fine. If anyone knows the MongoDB query to find something inside an array, please just put your hand up. Let me know. Otherwise, I will just look it up. That's what I need to do. Okay, that's not what I need to do. Oh, now I know why it's not working. That was my bad. I thought this would work, and it wasn't working, and it wasn't working because I typed a small g instead of a capital G. So that's why. Yep. So case is important. That's why it didn't work. So you can, if you just search for a string, then it'll find anything where the array contains that string. So if I change this to fire, it should find me Charmander among other things. Normal should find me a couple of different Pokemon here. Jigglypuff, Meowth, Eevee, they're all normal. Even this one's normal fairy, and the other two are just normal. If I wanted to find the normal and fairy Pokemon, then I would go all. query and find. And now it's only given me back Jigglypuff here. So we can write queries. So the basic queries for things like searching for strings within strings, greater than, less than, all that kind of thing. And then searching within the arrays there. So all that kind of thing we can query. Okay. So what else can we do with this? What's another query? So let's say let's make some different kind of data here. I'm going to add another collection here. This one, I'm going to call it people. And then I'm going to go back to ChatGPT and give me some more dummy data. I'll say, give me JSON data for, I don't know, 5 people. Each one should have a name and address. Each address should be an object with a street number, street name, and suburb. There we go. So I'm just getting ChatGPT to give me slightly more complex data now. So each one of these will have a name and an address, and we can search for things in these sort of sub objects. So if I copy that information there and stick it in here, add data, paste. So if I want to search for things that have street name of Oak Drive, for example, then I could go, so I can search using the dot notation here. So if I go address dot street name and then match Oak and go find, then it's found Michael Johnson here because his address's street name contains the text Oak. So if you have documents that have sub objects, you can search within those sub objects using the dot notation. Yep. Right. What else can we do? We've got 15 more minutes until the first break. Sorry. Yeah. I think we'll double check that. I just wanted to double check that everyone did have everything set up. If anyone's not been able to follow along with just playing around with this kind of stuff, put your hands up. I think we will make sure everyone is 100% ready to go before next session when we're going to start actually coding. So once you have done that, so fork the repository, clone it onto your local machine, and you'll have a folder that looks like this, which has a back end and a front end inside. And just to get everything working, can we, here, let's say if I open up this in Visual Studio Code, what I want to do is I want to make sure that the dependencies are all installed on both the front end and back end, and that I can run this thing properly. So here's everything. I'm gonna right click on my front end and open in integrated terminal. So I've got a terminal open in my front end folder. let's just wait for that to happen. There we go. And in there, I'm going to npm install to install my dependencies. And hopefully that will work all good. My laptop can just be a little bit slow sometimes. Yep, okay, that's all fine. And I'm going to do the same for my backend. I'm going to right-click my backend folder and go open in integrated terminal. So now I have two terminals open, and for my backend, I'm going to do exactly the same thing, npm install. And that's all working fine. And then for both my backend and front end as well, for my backend, I'm going to go npm run dev. And that should start me a local server running on port 3000. And on my front end terminal, npm run dev should start that Vite development server. And then if I open that in my browser, then I'll have something like this, which should look familiar if you went to last week's React workshop. So just before we go on a break, I want to make sure everyone's got to that point so they manage to npm install and npm run dev in both the front end and the back end folder of the repository without any errors. So if you did that and everything's working, fantastic. You can just play around with Compass for a few more minutes. Otherwise, if you need a hand getting this thing working, put your hand up and we'll come and assist you so that we know that when everyone is back from the break, everyone's ready to start coding. Yep, so stick your hand up if you need help here. So in our contacts app, in our backend, currently we have this data folder. And this data folder has a file called contactsdao.js. And let me just make my code a bit bigger for you all. Now, this file here has methods like retrieve contact, create contact, update contact. So basically, delete contact. So basically our CRUD methods. At the moment, all of these methods, they just interact with an array of contacts, which is what this variable is here. So it's just a JavaScript array. The data is coming from this initial contacts.js, which just contains a bunch of dummy data. We don't want to use this anymore. We want to actually use our database now that we have one. So what we're going to do is we're going to do a few things. We're going to create a schema, which tells us what is the structure of the data required by our application. And then we're going to use that in a couple of places. We're going to create a little mini program in this file here in initdb.js. We're going to create a little mini program to populate our database with some dummy data. And then we're going to modify our contacts.dao file here to connect to our real database instead of using that JSON data. So let's get started with that. Now, before we get started coding, I'll show you in the package.json, one of the dependencies of this project, which you'll already have because you've all done npm install, is Mongoose. And Mongoose is the npm package that allows our JavaScript code to interact with a MongoDB database. So that's there for us already, and we're going to be using that. So now let's create our schema. So what we're going to do is we're going to come over here to our data folder and we're going to right click new file. I'm going to call this schema.js. And what we're going to import, so you can follow along. By the way, if you get lost or later on, if you're having errors, all the code I'm going to be typing today is available in this gists, and the link here is available in the README. So if you go to the README, it's this link here, contains a bunch of code that we're going to be typing out today. Okay. So what we want to do here in our schema.js, the first thing we're going to do is import that Mongoose library. So import Mongoose from Mongoose, like so. And then we're going to create a schema which tells our program what is the structure of the data. And the structure for the data is pretty simple. So each contact just has a name, and that name is unique. So no two contacts can have the same name. And other than that, there's just a phone number and a photo URL, which is the image URL, and then a fun fact. Everything is a string. So let's create a schema for that. So we're going to go const contacts or contact schema equals, and I'm going to go new. So it's like creating a new object here, mongoose.schema. And then this has one argument that we're going to worry about for today. And that argument contains a bunch of properties that describe our data. So I'm going to put the squiggly brackets in there. Okay. So I've got new mongoose.schema and then a normal bracket, squiggly bracket, and then the closing ones here. And inside here, I'm going to type the information that we need. So if I go name, so this is saying my contact, all contacts have a name. And then each name is a string. And so comma separated list essentially here. They have a phone number, and we're going to say that those are strings as well. And a photo URL. Those are also strings, and a fun fact. Those are also strings. So just beware here, like casing is important, and the casing here is in camel case. So name is all lower, phone number, the N is capital, photo URL, the U is capital. Fun fact, the second F there is capital. So that's pretty much the most basic schema you can create. We're going to add just a little bit more information to this. So I said before that name is required. So if you can't have a contact with no name, but the other three here can be optional, that's fine. And also name must be unique. So we need to add more information. So instead of saying string here, I'm going to get rid of that. And I'm going to add a new squiggly bracket. And inside that squiggly bracket, I'm going to specify more information about the name property. So firstly, let's say that it has to be a string. Let's add that piece of information back. Now, if we're using the squiggly brackets to specify more information, it will be type string. So now this is the same as before, except now there's room here for us to add additional information. So I'm going to say required is true. That means that if you don't supply a name, it's an error. And then unique is true. That means that all contacts must have a unique name. So once I have the schema defined, the next thing I'm going to do is I'm essentially going to create a class which represents instances of our contacts. And I can do that, and this one I'm going to export so I can access it from other places in our program. So if I go export const, and I'll say it's called contact with a capital C because it's a class name, equals, and then I'm going to use the Mongoose's model function. So mongoose.model. In there, I give it two arguments. The first one is going to be essentially the name of that collection. So remember from before, we were playing around with collections in Compass. So the name of the collection, I'm going to call it contacts. And the second argument is going to be that schema object that we created up here. Okay. And that is the entire contents of this file, schema.js. So we're creating a schema that says each contact must have a name, which is required, is a string, and must be unique. And then optionally can have a phone number, photo, URL, and fun fact, which are also all strings. And then this part is creating a class. So later on in our code, I'll be able to go blah, blah, blah equals new contact to create a new contact instance. So if you're wondering, so if you search for schema.js in that gist that I linked before, which we can find here. So if you search schema.js, you'll eventually find it. It's here. So that's the same code there. So you can copy and paste this into your schema.js file if you like, or if you think that you typed it out correctly, then that's all good. So the next thing we're going to do is, okay, so we have a schema. Now we want to let's add some dummy data into our database. So let's create this program here for initdb.js. So it's given to you as a blank file. So I'm going to import Mongoose again. And I'm also going to import that contact that I just created, that contact class. Make sure if the autocomplete doesn't put .js at the end, you might want to add that, or you might get some errors. So import contact from ./schema.js. Now this file is going to be a program that runs by itself. So it's separate from your currently running web application. So what are we going to do? The first thing we want to do is connect to the database. Okay. Now, database operations are all asynchronous. So we'll need to await those or have them inside async functions. For Node.js, the root you can await things from the root in the latest versions of Node.js. So I can just go await mongoose.connect. And then here I'm going to put the connection string. Okay. So here's where I put, if I was over on Compass, if I was using my let's just disconnect that from a second. If I was using this, if I just copy this and paste that in here as a string, sometimes there are errors in Mongoose with using localhost. So to avoid that, I can change this to the other version. If I go 127.0.0.1 instead of localhost, that will get rid of those errors. And then the other thing I want to do is I want to add on to this connection string. So I don't just want to specify the host and port, but I want to specify a database. So for example, if I go back here into Compass, like I've got a whole bunch of databases here. Which one of these databases am I going to add this data to? You don't have to create the database first, by the way. If you're using Mongoose and you try to access a database that doesn't exist, it will create it for you. So I'll just my one I'm going to use, I already have one here. I'll delete this so that you can see that it will be recreated. Database. Okay, so I will use WDCC contacts app in there. So that's connecting, and then at the end of my file, it's good to disconnect from the database as well. And in the middle here, I'm gonna just create some dummy data that will be able to populate into that database. So if I wanted to make, for example, one contact and add that, I could do something like this. I could go const, don't bother typing this out. This is just a quick demo. So if I'm creating one new contact, I can do it like this. And then the information here, I can go name, Bob, phone number, for example, 1, 2, 3, 4, 5, etc., 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 and add the additional information. And then to actually save that to the database, I can go await my contact dot save. And then if I run this program, by the way, if you go to package.json in the backend and you can see another script in the DB. So if I open another terminal in my backend and go npm run init db. So I didn't put any console.logs or anything. It just ran and did its thing without printing anything to the console. I probably should have printed something like success, just so you knew it actually worked. But I've run that program, and now if I go back to Compass, if I refresh here, you can see that is created, and my contacts collection was automatically created, and the person Bob with phone number 1, 2, 3, 5, 4 got added. So all that was added when I ran that program. So I'm going to drop that database again, just so we can see. And I'm now going to, rather than typing everything out, I'm going to go into my own gists, which is this one. And I'm going to go and find initdb.js in here. And I'm going to copy this entire program, and then I'm going to sort of explain what it does. So copy, and back into my code, I'm going to get rid of what I had before, replace it with that. And then explaining what I'm doing here. So the first lines here, these lines are using another node package called .env. And what these let us do is it lets us read in environment variables for our program, which you can consider as basically configuration values. It lets us read those in from a file. And for many purposes, it's really good to store things like your database connection strings as environment variables. That way, if you need to change them, if you need to connect to a different database later on, for example, you can do that without editing your actual program code. So I'm reading in an environment variable called process.env.db URL, and that's where my connection string is coming from. I'll show you how to get that in a sec. So then I've connected to the database. I'm calling the contact objects delete many function, which is going to delete all the contacts from the database that are already there. This code here is fetching some dummy data from a website called randomuser.me and creating a bunch of contacts in my own database using the data from that website. I'm saving them all at once using the bulk save function and then disconnecting from the database. In terms of this environment variable, if you look here, there's a file called n.env.example. So you don't want to commit your actual env files to your Git repository. That would be bad practice, especially if they contain information like private API keys that you don't want to expose. But normally I like to create an env example file, so at least you can look at it and know the kind of information your program needs. So I'm going to copy that env.example file and paste, and I'm going to rename the copy to, I'm just going to rename it to .env. And then where it says your DB URL here, I'm going to put my connection string there to my database, which was, again, it was this / WDCC contacts DB or whatever. I don't mind if I'm creating it with a different name this time. That's fine. So this is the same, by the way, if you are using Atlas. It would be whatever your Atlas connection string was and then / your desired database name at the end. And again, I'm going to change this to 127001 because sometimes I have issues with that on my computer. And I just realized I deleted. There we go. So this is where it's getting the connection string from in here. And now if I run that same program, npm run initdb, it's going to run this code. And it said connected, it said disconnected, because this one actually has text. And if I go back to my compass here and connect, we can see that WDCC contacts DB is there, and it contains a bunch of dummy data, which was pulled from that external website. Okay. So I think now is a good time for us to make sure we're all on the same page. So if you cannot get this initdb code running, so if you've got an issue with the schema or the initdb program, please put your hands up and we will come around and help. Okay, so we have now gotten our database initialization. So we put some data in our database with JavaScript. So the next thing that we're going to do is we're going to modify our contacts DAO. So, okay, so contacts DAO is currently using this array, this normal JavaScript array. We don't want to do that. So what we're going to do is instead, so I'm going to comment out these two lines or just delete them entirely. We don't need those anymore. I'm not going to need this UUID thing anymore either, actually. So I'm going to just comment out all of those. And I'm going to replace these. I'll go one by one for these functions and replace what's in here with logic to essentially use our database. So I'm going to import. The first thing I'm going to do is import. I'm going to import that contact schema again. Make sure I change this to schema.js. And then, so retrieve contacts, this function just wants to give me back an array of all the contacts in my database. So I'll go return await contact dot find. And if I give this thing just an empty argument, it will find all the contacts because anything matches this query. So the find method will execute a query. The query parameters are given in this object here, but if I give no query parameters, which is what I'm doing here, it'll just find all the contacts in the database. I'm awaiting it because it's an async method. And then so this whole bit here that I've highlighted, this will be essentially an array of contacts that came from your database. And then I'm just returning that. So that's the easy one. Moving on. So here I've got some code here that's throwing exceptions if the name of the new contact is not unique or the name doesn't exist. I'm not going to worry about that code because the database code for adding a new contact is going to take care of that for me. So if I try and add a new contact that doesn't have a name or that the name is already taken, because I've defined my schema as saying name is required and name must be unique. If that means it's going to take care of that for me. So I can get rid of those. I don't need that exception handling code. I'll get rid of these lines as well. So I'm just leaving return DB contact. But what is DB contact? So let's create it. Const DB contact equals new contact. So I'm using that contact object. And then in there, I will just paste the contact that's coming in from this function. Then I will await DB contact.save. This line here will throw exceptions if the name is missing or not unique. So that's why I don't need this other code that I have up here. So yeah, create a new contact and then save it into the database and then return it. So returning the version of the contact that's from the database. This version of the contact that came from the database, that will have its ID field set. The ID field is automatically generated by the database. Then we have updating a contact. So this code is really messy and I don't really need any of it. So I will just get rid of all of that stuff. I could just delete it rather than comment it out, but yeah. This one, we can use a cool function. So if I go await contact dot find, if we look here, one of the functions that exists is this one. It's called find by ID and update. So if I do that, and then the first argument is going to be the ID of the contact, which is just coming from this function. And the second argument is all information we're using to update, which is coming from here. Okay, so basically this function will try and find a contact with the matching ID. If it exists, then it will update that contact using this information here. If it doesn't exist, then it will just not do any updates. This will return an object. It will return the contact that's updated. So I can use that because this function is supposed to return true if the contact was updated, false otherwise. So I can just say return, well, I'll use this syntax, which is like, that's not C. Essentially, if C is an actual object, then this will be true. If C is like null or undefined, then this will be false. That's a nice shorthand way in JavaScript of doing that. And then deleting. So again, I'll get rid of all the code that's in that function already. And I can just go await contact dot delete one. And I'm going to delete the contact where the ID of that contact is equal to the ID that is supplied here, like so. So I'm thinking to myself that this code probably works, but I'm just going to double check. So I had my backend running there. Let me just, if I just stop that running and start it again. Oh, I realized something I haven't done yet, which we'll get to. In my main application, I have not connected to the database at all yet. So if I try to go to right now, I'll just do it in my browser, localhost 3000 /contacts. Oh, it must be, I think it's /API/contacts. It's going to say my browser is sort of hanging a little bit. It's not really doing anything. And that's because, yeah, I tried to use database code, but I'm not connected to the database yet. So that's why that's happening. To avoid that error, I'm going to go to my app.js and I'm just going to go down here. Just before I start my Express server, I'm going to connect to the database here. So to do that, I'll import Mongoose again. And then here I'm going to have that same line that I had before, await mongoose.connect. And the same environment variable that I was using for my initdb script, I'm going to use here. That's another advantage of putting those things into environment variables, is I can use it in multiple places. And then if I change it, I only need to change it in one location and not multiple. Yeah. So now that I've done that line, and we can see that my app is running, so that connection worked fine. And if I pop back to my browser, we can see that now everything is fine. So my browser gave me back some JSON data according to those contacts which are in my database. So if I look at this data here, and if I open up Compass and compare this data to the data that's stored in my database, we can see, okay, we've got Yanko, Victoria, Joel, and over here, Yanko, Victoria, Joel. So we can see that the information returned by my API is exactly the data that's in my database. If we're running my front end here, again, we can see that, you know, my front end is set up to access data from my API, and because my API is returning data from the database, we can see that it's this data from the database is all being reported there. And if I want to edit, so let's edit this person. I'll change the fun fact of Victoria to, I don't know, what's fun about Victoria is named the same as the Queen. And then save. And we can see that fun fact has been updated on my screen. If I refresh the page here, we can see that that definitely persisted. If I go back to my contacts and refresh that, we can see that it got updated there. So that's exactly as we expect. If we go back to here and I refresh this, refresh, we can see that the fun fact got updated updated in the database as well. So definitely the communication from end to end is all working fine on my computer. So with that, there's only one more little change that we need to do to our program. And this is in preparation for our deployments later on. So the backend is now 100% ready to go for the deployment. The front end, though, we just want to make one small change to our front end code. Now, our front end has an API folder, and in that API folder, there's a file called api.js, and I'm hard coding here the URL where my backend is located. So this is in my front end source API, api.js. I don't want to hard code this. I want to change this to an environment variable as well, so that when we deploy, it'll be much easier for us to point our front end, which might be deployed in one location, towards our back end, which might be deployed in another location. So I'm just going to modify my front end to add the environment variable there. So like before, I'm going to copy my env.example. And then the copy, I'm going to rename that to just .env. And then my, so this is the environment variable I want, Vite API base URL. And I'm going to want it to be equal to this here. So I'll copy that, paste that in there. And then I'll just modify my api.js to access that environment variable instead of this hard-coded value. So it's not process.env. So for the backend, that's where you find your environment variables. But for the front end, it's a bit different. This is a Vite thing. It will stick your environment variables in somewhere called import.meta.env. I spelled that wrong. Import.meta.env. And then the name of the variable here. So copy that, paste that in there. And once we do that, save our API.js, just go back to our program here, refresh this, and everything seems to still be working fine. So yep, it's picked up our environment variable. Okay. Okay. By the way, notice how this environment variable has Vite as the first part of the name. You do have to name your environment variables that way if you're using Vite and you want to use those environment variables. If you don't name your environment variables starting with Vite underscore, then they won't be picked up by Vite. Okay, and with that, we have a full front-end, back-end, and database that is ready to be deployed, and Sean's going to be leading us through that after lunch. So it is pretty much lunchtime now, but we will, yeah, anyone, I think, WDCC exec, is the lunch ready to go, you know?
We don't know yet. She's back.
Oh, okay.
No, she's gonna do it here.
Oh, yeah. So lunch will be soon. Someone will tell you when there's lunch. But in the meantime, please put your hand up if you need help. Lots of people, yeah. So we'll make sure everyone is up to this point.
One host for deployment that is called DigitalOcean. DigitalOcean is a little bit like Heroku in terms of simplicity. There are lots of other deployment platforms out there, AWS, right, Azure, Netlify. But in terms of from an educational perspective, DigitalOcean is an excellent choice for beginners. Right, we'll start with DigitalOcean. It's not too simple where you are just handing everything off to someone for you to do, but it has the right level of configuration from an educational perspective. So one thing about DigitalOcean is I'm not 100% sure that we can get started with DigitalOcean today. I just signed up for it a few minutes ago and I got blocked because I already have an account, I believe. But for you guys, you should be fine. So just sign up, make sure you're not using a VPN or anything. And they ask for your credit card information in terms of how much it will cost. It'll cost no more than, well, for today, it'll cost no more than $1, hopefully. In terms, that's only if it's paid, but they also give you $200 credit, so it should cost you nothing today. Yeah, and then if you do leave things running and you want to keep it running, then it'll cost $4 per month. So it is very, very cheap in terms of compared to other systems out there. Okay, so that's just a little bit about cost. Basically, it should be free, but in the case it's not free, then it should be less than $1 for today, or roughly around $1. Cool. All right. So one more thing is if you did sign up here using the normal flow and you didn't get the $200, please try to sign up for the GitHub Student Developer Pack. That's a great pack to have as well. And that'll also be another pathway to getting that $200 in credit, which expires in a year. Cool. So a little bit about the structure of what we're doing today, a little bit about the theory. I invite you to have a little look at this diagram here. This is a simplistic diagram of what's going to happen and what you're going to do today in a very, very easy manner. This looks a little bit complicated, but not really. It's just a bunch of buttons and a lot of this all configured for you. Basically, what's going to happen is your users, when they access your application, they're going to hit something called a reverse proxy or load balancer. That is something that DigitalOcean does for you. It's invisible. Basically, it routes requests from your user to either your content delivery network, it's your front end, or your backend server, which is for a different path, which is /API. And then out in the wilderness somewhere, there will be a MongoDB, and that'll be a MongoDB Atlas. Your backend server. Okay. And then one more thing. So we had the same diagram, but just a little bit extra on the DevOps side of things. So we're going to also have a little bit of CI/CD today. Right, so that's built into the deployment. basically what's going to happen is DigitalOcean will link into your GitHub. There's a little bit of authorization involved, but it's just a few clicks again. Basically, what happens is when you push to the main branch on GitHub, DigitalOcean will detect that and automatically update your website within, say, 15 minutes. So that's super cool, and that's called CI/CD, continuous integration, continuous deployment. So basically, everything's really, really nicely packaged together today, right? Hopefully that makes a little bit of sense. When you push to your main branch, right, as long as that code works, DigitalOcean will deploy it and your users will see it within 15 minutes. Right. So moving on from there. So the slides here, there's a QR code if you want to look at the slides. I might copy and paste a few steps in there today. And moving on from there, so I encourage you to sign up for DigitalOcean. But again, right now I'll just go for a demonstration. So in DigitalOcean, you create a team. The team name here is called the Avengers. And then you have a project. In this case, it is called Fat Helicarrier. Right? Inside a Fat Helicarrier, then you might have something called an app. In this case, we have something that's called a Shawarma app. If you look at the Shawarma app, hopefully I'm pronouncing it right. You can see that it's deploying something. I'm not exactly sure what it is, but look at this. So we go to here and here. So this is something that you guys can all go to now. So this is your goal for the end of today. So the workshop in terms of time, we might not have too long to get to the very end, but basically I'll show you all the steps. So it'll be recorded as well. But your end goal is to have something like this available to everyone online. Right, you can see here, this is called Oyster app, Zim on DigitalOcean.app. And basically anyone can visit it right now, right? And add the information. Let's keep in mind, don't add in any critical information, right? Because the whole internet can see. I'm sure everyone here is trustworthy, right? But it's not just us that can access this website at the moment. Right. So let's get started. So I have a new project. I'm gonna call this something else. Let's call it, actually, let me just create a new project. So I'll show you all the things we need before I start working on DigitalOcean. Right. Cool. Right, so there is a repository that you guys can use if you haven't have your backend and frontend complete yet. WDCC also has another repository, which is the final version of the application, which you can deploy straight away, so you don't have to write any code. So this will be called the Education Workshop Final, and I'll pop that in the slides as well. But basically what you need to do, right, is you'll need to fork this repository, right? So in this case, just click on the fork button, right? And in the fork button, once you fork the repository, then you'll be able to link it to DigitalOcean. So in this case, you can see I'm currently on my own repository here, right? So Path to Live Education Workshop Final, and it says it's forked from the UA WDCC Education Workshop Final. So I'm pretty sure everyone knows how to fork today, right? And then it talks a little bit about running the server. So below are some details that are useful for running the server in production development mode. The backend, right, has a required thing in DB URL. Sorry, a required variable in the environment file. In this case, it's the DB URL. For MongoDB, we are currently embedding authentication information inside of it. So I'll show you guys how to get that all built. And then once you embed that into the backend will connect to the database, and then you can start the backend. For the front end, it's a little bit different. For front end, you have something called a Vite API-based URL, right? With the Vite API-based URL, it's pretty important to get it right because it tells the front end how to connect to your backend. Does that make sense? Right? So if you look at the diagram here, right, we have a front end and we have a backend server, right? Your .environment file, right, will be down here, and that'll tell you how do you. It'll show the backend server how do you connect to MongoDB. So that's the first part that we need to link up, right? And then another part that is not specified here is how does your front end, right, connect to your backend? So it will be this part. So we'll need to configure those two, and I'll show you that a little bit in a second, right? And just keep in mind, if you set the Vite API-based URL on the front end, you'll need to rebuild the entire front end. So DigitalOcean will do that for you as well. Okay. Cool. And hopefully you don't bring down anything important when you deploy today. Deployment's always a little bit of a nervous activity to do if you're doing something mission critical. All right. In this case, what I'll do right now is I'll actually not play around with VS Code for today. We'll just simply do a bunch of clicks. Right, so can I get a raise of hands? Who's got a MongoDB cluster? Ready? People? Oh, great, excellent. So a few people know how it works, how to configure it. All right, so for those who haven't got one yet, it's completely free to have a test configuration here. So basically you click create, right? Go to a shared cluster and select the free tier. It should be M0 sandblocks. So in this case, what I'll do is I'll delete this one and we'll start all from scratch. I usually call my cluster insecure delete monthly because for test purposes, I expose it to the entire world. So don't put anything mission critical in there. So allow me to make it longer, get done. All right, so we'll pop down here, we'll go to shared, right? And put in Sydney because I want my all my servers to be in Sydney. Of course, if there was an option for New Zealand, I would select that as well. Right. Go back to here and we'll do it slowly. So I go to database, I click build a cluster. This looks like it's giving me a little bit of a different UI now because perhaps I don't have cluster already, so it's giving me a different user interface. In this case, I'll call it something I want. Remember, you can't change the name after you've set it. So set it to something that is meaningful for development purposes. I'll automate the security setup, but there's one more thing I may need to configure, right? And that'll be it. I'll put it in Sydney. Right, and I'll make sure that I have a reasonable level of IQ. Oh, good. Right here. So once you've done that, pop down to security, right? So one thing to note right now is that you need to authorize a connection from DigitalOcean to your MongoDB database. That's what we're doing here now. I'm going to put in the entire world. Right, so add an IP address. Just type in 0.0.0.0. So 4 zeros or dots. 4 zeros or dots, okay, and then /0. That specifies it. Just keep that in mind. Right? But for purposes of development and things like that, that's perfectly fine, right? But if you're starting to hold sensitive data in there, then you may want to tighten things down. Right. Then you go into database access. In this case, you want to create a new user, right? Right, so let's add a new database user. In this case, I'm going to call this user, I don't know, Samuel Jackson. Right, and I'll auto-generate a secure password. I'll delete this later, so please don't hack my database. So I'll make everything public here. I will delete it later. And one more thing, add in built-in role, read write any database. Okay. Read write any database is a pretty important thing to put in there. Reason being is we're also going to specify the database name when we create when we link our server up to this cluster. Cool. So that's everything there. So we got Samuel Jackson as a user, and he has read write to any database. Right. Now, if you wanted to test the connection now, we can do that. So you open up MongoDB Compass, right? Click on the connect button and get the URL to connect. It'll be down here. Just basically click around until you find something that looks like this. This is MongoDB plus serve, right? Now let me paste this into my notes here. And I'll zoom in a little bit just so, oh, I can't zoom in. Don't know. How do I zoom? All right, Command Shift dot. So one thing that I want to point out to you, right? This thing from MongoDB Compass is your database connection string. That is very important for DigitalOcean to use. Very important for perhaps your local version of your server want to use as well. This will be your DB URL, sorry. Right. So you put this into your .environment file, right? DB URL would equal, right, this. One thing that you notice here, the username and password, not there yet. The username and password would be what you created on MongoDB Atlas. So we'll just need to paste that in here, like so. Right. And this is your DB URL, and this is what you're somehow put into DigitalOcean. So I'll show you how to do that. Once you put this into DigitalOcean in the right location, your backend server be able to access this and connect to MongoDB. One more thing that I haven't put in here, right, is before the question mark, just before the question mark here, you can actually specify the name of your database. In this case, I'm going to call this production. Okay. By default, if you don't specify anything, it'll select the test database. But if you put in production here, or whatever you want, then it will specify and create a specific database for you to connect to, or for your backend server to connect to. And so this completes all of the setup for your database. Okay, that's all of the setup done for your database. You have all the information you need now, and you need to somehow set it onto your backend server. Okay, so now this is where we pop into our project here, right? In this case, let's just reuse the same project. I'm sure you guys will have a project as well, right? And we'll add another app to it. So everyone see this big green button called create? Yeah. So that's the button you use to create the application, right? And the application is literally an app, such as like a full stack app, right? An application can contain multiple things inside of it. So this is what we're going to do now. Right, so here we're going to go to our app platform, and we'll use this to deploy our code somehow. Right? Droplets are quite fun to use as well if you want to play around with Linux. That app platform is a fairly low code solution that gives you a little bit of customization as well. Right, so let's select that and see what happens. I am clicking on it. I'm not trolling. Yeah, okay, it is working. Okay, cool, great. Right, so this is, you should be presented with something that looks like this. We're going to use GitHub as a service provider. Right, and at this step, what we're going to do is we're going to somehow tell the DigitalOcean. This is how we deploy our app. This is our repository. This is how you're going to be able to run application in production mode. So that's what all we're going to do here. It's a bunch of clicking that tells DigitalOcean how to deploy our application. In this case, when I select GitHub, right, and you may need to install DigitalOcean. So in this case, you might be presenting something like this, right? It won't be the exact same buttons that I clicked because I've already authorized it, but just for demonstration purposes, right? Make sure you give DigitalOcean access to the repository that you wanted to access. In this case, I only gave it access to the education workshop final repository, right? But if you feel comfortable enough, you can give it access to everything. So let's go back to DigitalOcean. So that UI that I just showed you, that may be a little bit different to you guys, but that's completely fine. It's quite simple to do. Right? The only thing that you have to understand is that you must have a forked repository, a repository that you control. If it's on the WDCC organization on GitHub, you cannot the DigitalOcean access. Just keep that in mind. It has to be something that you have appropriate privileges to install DigitalOcean as a connection. In this case, Path to Life Education Workshop Final, right? And then we're going to specify the main branch and the source directory. The source directory is optional path to the directory to the build relative to the root or the repo. Right, in this case, we're going to build the front end only, and then we move on. Auto deploy, that's pretty self-explanatory. If you read through it, it says every time an update is made to the main branch, application will be redeployed. I do want that, so let's keep that in there. The source directory, we're going to focus on the front end for now. So how do I know it's called a front end? So it's simple. It's basically what folders is in your repository. You see we have a back end and we have a front end. When I type in /front end, I'm specifying the front end folder. Okay. And this is then a point where I stop and I direct you to a resource. Right. When you have backend and front end in the same repository, that is known as a monorepo. The word monorepo. It's a way of managing a full stack project in Git, right? And it can be a little bit complex to work with when you're deploying. So if you go to DigitalOcean, right, and you type in the word deploy monorepo, and I'll give this link to you guys as well. It'll actually give you quite a nice little step through how you can deploy this application for exactly what you've been working on for today, right? Which is an application where you have backend and frontend all in the same Git repository. Right. And then, so with that, DigitalOcean gives you a nice little guide. So I'll pop that into the slides there as well. Okay. Right. So if you read through it, basically it's pretty self-explanatory. However, you want to really follow through with what I'm doing today, because I have the configurations with more precise variables that we need to put in there specific to this application. Whereas this guide here will only tell you general information, won't be as helpful as the recording that you have. Okay, so what's here? Okay. So we have a first application here. It's already generated a name. It's called Seal App, right? And you'll notice that it has Education Workshop Final front end. In this case, I'm going to configure it. Make sure you click on the configuration button. All right, so this is where you have a bit of a interesting thing that you have to just basically deal with when you're deploying online. Azure and AWS is a little bit more bad with this. DigitalOcean not so much. But basically, it is the default resource size for an application. I believe in Azure, they try to charge you $89 per month or something by default, whereas in DigitalOcean, they try to charge you $12 by default. The thing is if someone plays around with any sort of deployment platform and they don't bother to look at things precisely, they're gonna waste money. Okay, so make sure you click through things, right? Be very, very careful. And this is where you configure it, so you do save a bit of money. Okay, just keep that in mind. Right? All the platforms, Azure and AWS are a little bit more scary. Just be very, very careful when you're deploying something. Always check for the resource size. Right. So that's the first part here for your front end, right? But in this case, we're actually gonna set your front end as a static site. Okay, so it's not a web service, it's gonna be a static site. So you're wondering what's the difference between a web service and a static site? Well, a static site doesn't use any CPU power. Okay, a static site is simply a bunch of files. Now, if you're wondering why is the front end okay to be just a bunch of files, let me show you now. So I'll go into a little bit of detail here, right? So I'll quickly clone Education Workshop Final, right? I'll cd into front end, right? You've been working on the front end today, right? Everyone's very familiar with this? Good, good, great. So I'm gonna quickly npm install, right? I wanna now npm run dev. Okay. So that's your front end, right? And you're currently thinking, how does the front end not use any CPU power? Well, this is the development version of the front end, okay? This is your development version of the front end. Look at all of these files. When I play with a full stack application, right, of some sort, right, and I load the application into, or the front end into the web browser, you see this? These are all individual files. These are all files. The thing is when you have a deployment, right, these files are actually all combined together into a few, maybe 4 files max, right? And these files will be served to your users, right? These files will be served to your users, right? And then your users' browsers will run these files. This will be your front end, right? If you're sending an image to your users will run the image. Does that make sense? So that means, right, when you're on DigitalOcean or when you're deploying a front end, your server on DigitalOcean for the front end actually doesn't need to do any computing. It only needs to give each of the users perhaps JavaScript files, perhaps a CSS file, perhaps a bit of HTML, but it's just serving files. It is not computing those files at all. It's just giving people files. So let me show you now exactly what sort of files will be given to the users. I'm typing npm run build. You notice here, everyone see this gray folder? It's a new folder called dist. If you're looking here, what sort of unique files do we have? Can someone tell me? See, what's the SVG? What's the SVG? Andrew, what's the SVG? Scale vector graphics. Okay, so these are your icons, okay, guys? So these are images, right, that are used on your web page. HTML, who knows what HTML is? Yeah, good, great. So we got your HTML, then we got something that looks like, oh, whoa, what is this? JavaScript. That's a lot of JavaScript. Right? This is automatically generated as part of the build process. So after you've built your backend, all of the JavaScript gets combined together into actually one JavaScript file. And you see CSS as well. Right? So all of that combined together serves as your production build. Now, what I'll do quickly now is simulate a production server scenario. So I'll type in npx serve list. Right. And this will simulate what DigitalOcean will be doing. Right. How many files are here? Ignore the context. Look, we have the HTTP, we have CSS, we have JavaScript. You actually have your local host, which is your HTML, right? So this is what your end users will be given. This is your production version of your front end. This is a static site. It's only a few files. Right? So when you go to, say, I don't know, any sort of production site that uses React, you know that the site loads actually pretty fast. And you look at the network and a few files, and the files aren't readable. This is the production build, right? And this is what developers, right, experienced ones, do to put their applications online for the world to consume, right? Again, one thing to understand is the JavaScript file is using your computer for processing power. It is not using DigitalOcean. That's why for the front end, we use a static site, okay? The back end now, that's a completely different story. Right? Raise your hand if you think it needs to use processing power on the DigitalOcean. Raise your hands. Excellent, great. So now you know, right? Your back end does need to have a little bit higher cost, whereas the front end, not so much. The hardest part about your front end is to just make sure that your images aren't too large. Otherwise, you have a lot of bandwidth required, right? Any questions so far before we move on? Oh, cool, great. So one thing to identify is once you select the static site, not there. A static site that for DigitalOcean is actually, I don't know how it works. It's definitely free. The static sites are actually free. But keep in mind, I think you may have to have a backend as well. So you're still paying like for the backend, and then like static sites like complementary. Right? Cool. Next thing, who knows this command? npm run build. Yeah, there it is. So DigitalOcean is very, very nice to use, right? But you still need to understand some of the fundamentals for when things go wrong. But if you're lucky, okay, you don't understand it still work. But the thing is that DigitalOcean really knows, and it's detected that this is most likely some sort of React site, and it's pre-populated some common configurations. In this case, npm run build. The output directory is auto as well. So I'm going to trust him to automatically figure out the output directory. And basically what it's meaning by output directory is which folder is your production build? Where are all the files stored in your repository built? And the answer is in this folder, right? A folder, technically the front end project, and then this folder. Those are where the important files are for DigitalOcean to deploy. Right, but I'll leave it as auto because DigitalOcean, whoever's created the system is very familiar with React websites, so they've configured something that's pretty nice and easy to use. And then finally, this is the HTTP request routes for a front end. So if you go back to your WDCC deployment here, right, this is your route path, and this is what your users will be hitting when they come to your website for the first time. So go type in type in HTTPS, DigitalOcean.net, without typing anything with a slash, and they'll be taken directly to your site. This is where you configure that behavior, right? Where you just put in the slash by itself. And that means anyone who's coming to your site for the first time will be directed directly to your production build of your front end. Okay. One more thing is that I can't specify here, right? But we'll specify later, is the connection from your front end to your backend server. Right? This is where your front end somehow knows the path that it needs to go to contact your backend server. But we'll configure that in a later step. So one thing to identify right now is I haven't specified it here. So that means that even if I deploy the front end right now, my front end will not be able to contact the backend server because it doesn't know. It's not specified currently. So I'll specify that at a later stage. Right, cool. So that's everything for the front end. Right, go back here. And this is where I can specify the connection between the front end and the back end. But before I do that, let's add in something else. Don't know exactly where, but we'll figure it out. I'm looking for a plus button to add the backend, but I don't see it. It's okay. What we'll do is we'll just build the application and we'll add in the backend later. So if someone does work out how to add in the backend here in the initial creation step, then great. But for now, let's just quickly build or create it, and then I'll show you where you can add it to the application. Okay, cool. So now we have the application, right? And it has the front end inside of it. Let's add in the front end. So basically what you do is you click around and find the location to add in the front end. Oh yeah, where is it? So there's one thing about playing around with the deployment system is sometimes it's very hard to find. Okay, so I think it just creates resources from source code. Right, so add another resource. Right, in this case, I'm gonna type in the word backend. So same thing again, right? Just make sure you're in the right application. Right, so let me go back to the very start. So this is the Seal app that you just created. You notice at the top right, there are some global configurations or actions you could do. In this case, I am going to add in another resource. Okay, so that's what you need to do. You can just add in another resource. One thing you notice here is that it's currently deploying the front end, but we all know that the front end is not linked up. The back end doesn't exist yet. So this is what we do now. Okay, so let's basically set the same thing again. In this case, instead of typing backend, we're gonna instead of typing front end, we're gonna type in backend. Right, and we'll keep it as usual. Right, so few steps. Okay, and remember, make sure you're on the $5 plan, right? And this time we're going to keep it as a web service with Node.js. Right here. Okay, and yeah, we'll do npm start. Okay. So can someone tell me, right, when you're currently working on your backend, what is the command that you run to start your backend? Anyone know? Huh? Anyone know? npm run dev, right? Yes. So npm run dev, and it starts your backend sometime. Another thing to identify is that you also have another one called npm run start. So in this case, our backend is actually fairly comprehensive. It's very, very simple and easy to use, right? But if you're in a different environment, it's very common for you to have to build your backend as well, right? So for the purposes of production deployment, we've simulated a production mode for your backend, right? Which is npm run start. Right? So don't run npm run dev because and for a different application, they'll start your backend in development mode, right? Do npm run start to start it in production mode. Okay. So that's what we're doing now. So we're here, we have run command npm start. And one more thing is you don't need to build this backend, but in some other backends, such as the TypeScript backend, you need to convert a TypeScript into JavaScript, maybe minify it, right? And then run the npm run start command. Right, and HTTP port, we'll leave it as 8080. Right, and your request routes, this is the important part. Does anyone know what I should be specifying for the request route for the backend? Shouldn't be this. This is education workshop final backend. Anyone know? There'll be 3 letters. API, excellent, great. Why? Why API? Well, it's because we've decided to design it that way. The path will be API. That's important to understand because you are connecting your front end to your backend, right? You need to have that path specified in your front end, right? So API. And save that. Okay. Click next. And environment variables. Does anyone know what sort of environment variable I need for my backend? What does my backend depend on? The backend can run perfectly fine without a front end, but something it needs something else. Backend will not run right now. Why would it not run? Where does it store the data? Excellent. Yes, so it's a database. This is where all of the configuration we did at the beginning comes in. Right. Right. So this is another thing that I want to show you guys, right? Is that environment variables are super important. You never commit these environment variables to GitHub. Who thinks this is a good idea to commit this to GitHub? No, don't put it on GitHub, right? Environment variables usually you don't store them anywhere on the computer as well because they can contain some very sensitive data. Right? You usually store them on your deployment platform, right? So pop them in a deployment platform somewhere. In this case, we pop it here. So there's the value and the key. I wonder what the key is. Not magical, right? Every server is unique, right? To work out the key, either read through the documentation, right? Or have a look at what's in there. In this case, right, environment.examples already told us, right? README's already told us. But what if there wasn't an environment example, right? What you would do now is read through the code and have a look. Where is it going? Oh, there it is. Process.environment DD URL. So that's how I know this is the source of truth, right? You don't documentation's there for your convenience, but sometimes documentation can be wrong. Source of truth is read through the code. Okay, 125 on local server. This is where it's actually accessing the DB URL. So I grab that and copy that, and I go back to DigitalOcean, and I YOLO that somewhere left-hand side. Right. So what will happen is magically, basically, on the server, DigitalOcean starts it up. So to configure this server environment to have something called DB URL specified, and Node.js will detect that as specified in the process.environment, right? Node.js will detect that and grab the value there. One more thing it asks is, would you like to encrypt it? So basically what happens when you tick that, it means that once you save this, right, this panel here, and upload everything, it's impossible for even you as an admin to get the value on the right-hand side. Right? The value is locked on DigitalOcean now. It's impossible to get it back out. Right? The only thing that has really access to it is your server. Right? So you could say, okay, what if a hacker deployed some sort of application and then console logged the value? Yeah, sure. They can still retrieve it somehow through a roundabout way, but directly on the platform through the website now, it's impossible to get that MongoDB value. All right, cool. So that's Samuel Jackson, production server on there now. Cool. And I think that's everything. Radio, and I verify that I'm not wasting money, right? And we're good to go. So this will cost $5 per month, USD, by the way, but shouldn't need to pay for it if you're subscribed properly as a student. Cool. So that's our backend going away and deploying. So now I'll just verify that my front end has the right environment variables. So it's the final front end. So you can see here, right, on your application, I'm clicking around a lot. But basically you have your app, right, which is the overall thing. And then you have your backend, and then you have your front end, which are components, or this is also referred to as resources. What I want to validate right now is that my front end has the right connection to the backend. In this case, it seems like it does not. Right. So if you look at back to the code here and look at the front end, right? This is the environment variable that you specify to connect to the backend. Okay. That's the environment variable. Then you have the site. One thing to identify though is, well, I just told you that your front end does not require any sort of computing power, right? So you're wondering, how does this bind API, how variable, how does it embed itself into something like this? Right, the answer is that it embeds itself during the build. Okay? So what this means is that when you specify the environment variable in DigitalOcean, you must rebuild the entire application, and the environment variable must be available during the build phase. Right. After the build phase, then the environment variable is no longer read because the information is embedded in the actual JavaScript. Does that make sense? Okay. So that's a little bit different between the front end and the back end. The back end is able to read the environment variable as it starts up, so you don't need to rebuild the back end. Whereas with the front end, you must build to embed the information. All right, so let's quickly embed the information now. Vite API-based URL, and the value will be just /API. The reason why it's just /API is because the front end and the back end will be both on the same domain. Okay, so I just don't need to type in anything there. But if they're on a different domain, you know, maybe you have to type in here HTTPS, right? Google Firebase, something like that, right? .app.io, I don't know, ending /. But in this case, because they're both on the same thing, right? Same domain. The browser can remember in HTML, right? If you type in HTML image source, it can do / something very similar here. You just do / for the same domain, right? So save that in there. I'm not going to encrypt it because I want to be able to view it in the future. Right? It's not a sensitive variable. And then I pop that in there, and hopefully, it'll start building and everything will go on. So let's pop the DigitalOcean in that application right now. Right? It should be deployed, but it should have this error. Right, you can see right now it's failed to load resource. The server responded with a status of undefined. Right, undefined context 1. That's because currently the environment variable for backend is not embedded. It's undergoing the build phase as we speak. Right, so hopefully when I refresh later on, now this error will disappear, and the undefined variable will be replaced with /API. Okay. So hopefully that'll happen in the next few minutes. Right, so we go to deploy logs and have a look. Basically, it's deploying the front end as we speak. That's the back end, and the front end, yeah, just going through. Is it me? Or is it saying the word Heroku? Okay. I didn't know DigitalOcean had some sort of partnership with Heroku. Right. All right, so this is where we go for our first little bit of an error, which is fine. There's 404 not found, but it is. You can see now it has API embedded. And this is now where we go for a little bit of debugging, and we have a look through. First thing that I want to do is make sure that my API is online. So have a little look. Yeah, it looks like the API is online with the /context. Okay. API /context. Okay, so this is where I need to double check. Is it API /API? Okay. So one more thing. Right. To be very careful with pathing. So I'll go back to the diagram here. So I've had a little bit of this configuration with this proxy load balancer. Basically, what's going on is I'm configuring /API on the front end. What's happening is when I type in /API here, right? What's actually happening, it's hiding /API, right? And it's passing to the server just the /. Just removing API. Right? But the server code is designed to look for the API route, right? And so for me to get around it, what I'm doing right now, I have to type in /API. Because what's happening when the user types in /API, it goes through the reverse proxy and load balancer, and it becomes just API by itself. Okay, so what's happening is the load balancer is removing one of the /APIs. I need to get around that right now, so I'll quickly show you. Right. So that's another thing to do with deployment, and it's something to do with HTTP path rewrites. So I'm just going to look around. I was configuring it just before. right? Somewhere in the actual Insights application itself. And once we get that done, we should be all done. Excuse me. The SEO app and up there. So go to the back end, the routes. There we go. Right. So the way to go it is just the way to find it is you need to go to the resource, the backend resource, go all the way down into your HTTP request routes and make sure you tick preserve path prefix. Think about that. Without that tick, it won't preserve it. We'll actually remove path prefix and we type in /API because the first API we remove. You click preserve path prefix, I think it'll preserve the /API and pass it to the server, and the server will know actually what you are hitting. So keep that in there. Click save there, and then we should be all good to go. Right, and I don't think we need to do a redeploy, I believe. But I'll just double check the deploy logs while we're here at it. Yeah, we should be good to go. Right. So I go to here and on that. All right, we'll go here. Oh, hello. Did someone troll me and put something in the production database? It looks like someone did troll me today. All right, cool. So we go to browse collections and do a little look. Yeah, random user. All right. Thank you very much for trolling me today. Radio. Well, so in that case, that finishes off the demonstration. Any questions so far? Everything's deployed now. Any questions? In that case, feel free to try deployment for yourself, and if you come across any problems, I'll walk around. Yeah, question? Okay, cool. Great. All right, thanks, guys. There you go.